What I want to do in this video is talk about a bunch of molecules or classes of molecules that can be derived from carboxylic acid. And just to show kind of a specific example, I'll show things that can be derived from acetic acid. And just as a review, acetic acid looks like this. Acetic acid looks like this. And the common name, as I just said, is acetic acid. And if you want to use the systematic name, you look for the longest chain, which is right over there. There's 2 carbons, so we use the eth prefix. So it's ethane. And since this is a carboxylic acid, it is ethanoic acid. Now, the derivatives of acetic acid, and we can later generalize this to all carboxylic acids. We really just have to change what's going on this carbon chain right here. It won't have to necessarily just be 2 carbons. It could just keep going, have benzene rings, whatever, and that would change the name. But really, I just want to give you the gist and the gist of the naming. So if we were to replace this hydroxyl group with an amine, and in future videos we'll see how that is done. So if we were to, so let me just draw the acyl group. So the acyl group is just that right over there. And we're just going to keep changing what's bonded to the acyl group right over here. So if this is bonded to an amine, so let me draw, well, this would be the simplest amine right over here, which would be NH2. This thing right here is called an amide, or an amide. An amide. And if we were to give this its common name, this would be acetamide. This particular example would be acetamide. I should maybe acetamide. And if we wanted the systematic name for it, it would be ethanamide. You have 2 carbons right there. So it is ethanamide. Now, the natural question is, all amines won't just be primary. You might have other things other than hydrogens attached to it, other radical groups, other carbon chains. So how do you name those? And so if you had a molecule that looked like this, and actually let me just change things up a little bit so that we diverge a little bit from the ethane root. So let's say you had 3 carbons bonded, or part of the acyl group right there. And then we are bonded to a nitrogen, which is bonded to a methyl group, and then another hydrogen. In this case, you start naming with this methyl group right here. And to show that that methyl group is attached to the nitrogen, you call this N-methyl. And then you look at the chain that forms the acyl group, the carbon chain. We have 1, 2, 3 carbons. So it is propanamide. Propanamide. If you had another methyl here, you would say N, N dimethyl. If you had a methyl here and a propyl group here, you would have called it N-methyl, N-propyl, propanamide. So hopefully that gives you a sense of amides. Now, and this is something we've seen before, so it's a little bit of review. If you have something that looks like this, I'll have it attached to a methyl group right over here. We've seen this before. This is an ester. This is an ester. And if we have, let me make the part that makes it an ester in blue to differentiate it. We keep substituting what is attached to the acyl group. Let me label it. This right here is called an acyl group. That right there is an acyl group. So right over here for the ester, if we were to give it its common name, and we've seen this ester before, it is acetate. And if we wanted to give it its systematic name, you look at the longest chain, 1, 2 carbons. So it is ethane. And you don't call it ethanoic acid anymore. You call it ethanoate. Ethanoate, just like that. Now, the next one, and we haven't seen this one before, and it looks complex, but when you really break it down into its constituents, it's not so bad. So let's say we have a molecule that looks like this. So we have one acyl group, and then you have bonded to an oxygen, which is bonded to another acyl group. So it's almost like you have two carboxylic acids that have been joined together. And you really do have two acyl groups joined by an oxygen here. This is called an anhydride. Anhydride. And they look very complex, but you just have to realize they're two carboxylic acids attached to each other, and usually the same one. Most anhydrides you're going to see in organic chemistry are formed from the same carboxylic acid. So however many carbons you have on this end, you're normally going to have on this end. So the way to name these is you name it just the same way that you would have named the carboxylic acid. But instead of writing the word acid, you write the word anhydride. So this right here would be acetic anhydride. It's derived from acetic acid. This right here is acetic anhydride. Anhydride. Or the systematic name is, you have 2 carbons. So it's ethanoic anhydride. And just to make things clear, if this molecule, instead of that, if we had something that looked like this. If we had something that looked like this, where the carbon chains on either end had 3 carbons, 1, 2, 3, 1, 2, 3, we would call this propanoic anhydride. Propanoic anhydride. In the unusual circumstance, and it is unusual, where you would see different carbon chains here, you would list each of them. So if this had 2 here and 3 here, it would be ethanoic, propanoic, anhydride. But that is very, very unusual. Normally, these carbon chains on either end of or both acyl groups will contain the same number of carbons. Now, the last carboxylic acid derivative that you should know about, and we've already seen it, are the acyl halides, and in particular the acyl chlorides. So let me draw it right over here. So you have your acyl group. You have your acyl group right there, and then it is bonded to a chlorine. And this right here is an acyl chloride. Maybe the most intuitive name. This right here is an acyl group, and then you have a chlorine. So it's an acyl chloride. And we've seen this exact acyl chloride. It's derived from acetic acid. So this is acetyl chloride. And this right here is acetyl chloride. Acetyl chloride. But if you wanted to give it its systematic name, and we haven't seen its systematic name before, we have 2 carbons. So it is ethanoyl. This tells us that we are dealing with an acyl group. Ethanoyl chloride. Ethanoyl chloride is how we would name this. And if this had 3 carbons, it would be propanoyl chloride. So hopefully that gives you at least a good introduction to the differences in structures of all these groups and an introduction to naming them. In the next video, we'll talk a little bit about the relative stabilities, and then it'll give you a good intuition on which direction a reaction might go. Are you more likely to go from an amide or an amide to an acyl chloride, or from an acyl chloride to an amide, or anything in between?